Does this look familiar? You pull a standard base image, you run a security scan, and suddenly you are drowning in vulnerabilities. You haven't even written a single line of code yet, and your security team is already flagging your containers. It's frustrating, it's risky, and honestly, it's unnecessary. Today we are going to fixing this using Docker Hardened Images. In this video, I'm going to show you exactly how to swap your standard base image with Docker Hardened versions. Let's take a look at it. In December 17th, 2024, Docker has announced that they are going to offer free Docker Hardened images for public. So that means as a user of Docker images, we can have access to well secured hardened images for our application. So this is a very big step from Docker because most of the other platforms provide hardened images as an enterprise solution or paid solution, but Docker come up with offering free Docker hardened images for anyone who are using need considerations for security and improving the security posture of the Docker images. So from this blog post, you can see that the announcement, right? So we are going to take a look at from the demo how we can use the Docker hard images, and we will do a comparison between normal standard image and the hardened image, and we see the difference in our own. And additionally, we will see some security implementations that are added to the Docker hardened images as well. Okay, now let's take a look at where we can find these Docker hardened images. So if you're already familiar with Docker Hub, right? So if you go to the Docker Hub, you will find hardened images section, or you can Google Docker hardened images. Then you will get a link to the Docker hardened images hub, right? So in here you can find many hardened images for your need. So for example, you can find traffic Helm charts. And another good thing about is this is not only Docker images, you have other type of artifacts as well, like Helm charts as well. So that's a very good thing for companies or the organizations or individuals who are using cloud native Docker or images for their applications, right? So let's take a look at the Docker hub for the hardened images, right? So here you can find Helm chart that is using hardened images for traffic. Then you have PHP. Then you have Kafka, Redbit, RabbitMQ images. Likewise, there are many variety of images are available here. So if you click one of these images, right, you will see information about the image, and if there are any security certifications like FIPS, CIS, those kind of things, that means this image is compliant with those security compliances. So if your organization is bound to follow these different compliances, then you can use these images, right? Then in the right side you can find how we can use this image. And if you notice that the for hardened images it has a different base URL, it is not anymore like docker.io, so it will replace from dhi.io. So that's the that's the information that you need to know, right? Then you can find different image pushes, right? So in here you can find a lot of things, information about this image, and you can see the vulnerability uh, guideline and how much of how many packages are included in this image. So we will discuss those things in detail when we are doing the demo, right? Then additionally, if you want to learn more about Docker Hardened Images, then I highly recommend you to go into the Docker Hardened Images documentation. In there you can find many informations about hardened images, free tier and the enterprise tier as well. So yeah, it's a good place to get more information about Docker Hardened Images. Okay, now let's take a look at the demo, right? For your information, this demo is available in the GitHub. So I will share the link for the GitHub repository so you can try with your own, right? And you can find it in this URL. So anyway, I will post it in the description of the video. In this demo, we are going to take a look at how the standard Docker image is different from the Docker Hardened image. So for that, I have prepared some commands in the GitHub repository. So there's a file called command.sh. You can use that file to run these commands. And additionally, I have included a very simple Python application, right? So it's not that complicated. So, and I have included some Docker files in those Python applications. So to try out these demos. So first we are going to take a look at first part of our testing, right? So first part of our demo. So in this demo, we are going to build a standard image using a Dockerfile. Then we will in the second part, we are going to build the same application with Docker Hardened Image, and finally we are going to compare those two images and see how it's going to be different, right? So in the folder you can find the subfolder called standard images, right? So under the standard images you can find the Python application. It's a very simple Python application, nothing complicated. Then you can find the Docker file for that standard image testing, right? So here you can see I'm using the from command and Python. So this is actually image from the Docker hub, right? So then I'm putting working directories, then I will copy the requirement.txt, then I will install any dependencies for this simple application using pip install. Then I will copy the app.python, then expose the application through port 8000, and in the end I am running the cmd entry point for the Docker file, right? Entry point for the command container, right? Okay, so here I had some characteristics as well for this image, right? So you can see this is an official Python image, and it is running as root user and full OS package, include all full of OS package, and it includes shell and package managers, and I have, right? So first we will build this image, right? So I will copy the command, then I will run it. I'm going to run with dash dash uh, no cache, right? Because I want to show you how it's going to happen, because before I record this demo I already run it, so it will take it from the cache. So if you put no cache, it will going to get it. Okay, so I'm in the wrong directory, so I will I'm going to the correct directory. I will run the no command for building the Docker file or Docker image, right? So here you can see it is very quick, nothing complicated. It's very simple application. So now the image is built. So if I run and view the container images, you can see the image is there. So, and this is the image name, Docker demo dash app standard tag. Then you can see the size of the image is 1.4 GB after the installation of the packages, right? Then we will do a vulnerability scan with the scout, right? To see whether there are any vulnerabilities available in this image, right? So because you are not going to see any outputs, because I'm using redirection, and I will only output the last 10 numbers, because the scout CVS command is very extensive, and it will show you all the information and all the CVEs and everything. So I just want to give you only the summary, but if you want to see the entire output, then remove the redirections and the piping of the for filtration. Now the scan is completed. So if you take the last 10 lines, then you can see I don't have any critical vulnerabilities for this image, but I have high, medium, low, and other unspecified vulnerabilities, right? So you can see you have many vulnerabilities in this image, even it is the official Python image for from the Docker Hub. Right? Then let's run the application through the Docker container, right? So yeah, I already have image container, so let's delete it. Okay, now if I type Docker container ls, so then you can see this also need to be removed, the DHI app, so remove it. So if I type Docker container ls, then you can see the Docker container that is running from the image that we already created, right? Okay, now we'll do some testing whether the application is working, right? So now you can see it is giving some information, right? Running status and Python version and other information that can be taken from the Python app, right? Okay, now you can you see you notice that standard image contain many vulnerabilities, right? So now the second part of this demo, we are going to take a look at the hardened image. So for that, I have a separate folder called dhi-image. So in there also you can find the Python application and as well as dockerfile.dhi. It's a Docker file that we use to build this same Python application, but the difference is we are going to use Docker Hardened Images instead of the official image in Docker Hub. Right. So here you can see that we are going to use multi-stage build, right? You may think why we are going to use multi-stage build for hardened images, because if you use the hardened images, then it is minimal and stripped down. Because of that, you don't find the development tools and other tools like CLI, shell, and those kind of things. Because of that, you cannot build on top of the DHI Docker Hardened Image Python official the Python image. Because of that, Docker has provided specific image for their building purpose. So most of the hardened images has a tag that called dash dev. So this dash dev tag can be used to build the application, then move the compile binaries and all of these things to the runtime image. From that, you can make sure that your application is much more secure. So that's what we are going to do here. So we have two stages as a builder stage and the runtime stage, right? So in the builder stage, you have using the Python Docker Hardened Image Python 3.13 dev tag. Then we will build the image through the Python and we'll install every required dependencies and packages. Then the second stage, we are going to copy the virtual environment and the required Python binaries, and we will expose the application. Then we will add the CMD entry point for the Dockerfile so the container can start the Python application. So here I also add some benefits for the DHI image, right? So you can go through them. So one of the main thing about DHI image is it is minimal, right? And it is way less, the size wise, the image size is very less compared to the normal Docker image. And it is running as non-root user, right? If you have a standard image, then you can run it as a root user. It's a security risk. Then you have minimal packages. We'll do a comparison in the next stage and see all of these package differences and things. Then almost non-zero CVEs in the hardened images, right? And no shell and those kind of things are included, so it will reduce the attack surface as well, right? So now we are going to build this image, right? So I will run the command. Yeah, before you run the command, you have to make sure that you are logged into the Docker Hub first, right? So you have to run docker login dhi.io. As I mentioned, the Docker Hardened Image use a different repository in the sense, right? So you have to make sure you are logging in. Because I already log in, it will take the credentials that are stored in my local machine. But if it is your first time, then you'll ask for your username and the password to add to and you can authenticate with Docker. Then what I'll do is I will build the Docker DHI image, right? So okay, I will use the no cache. Okay, so it's going to use Python, and you can see the stages, right? So this is the first stage, right? Then we can see the builder stage is coming here. Then the second stage is the will copy the content from the build to the runtime image, right? Now we have built the image. Now we can view the image, right? So here you can see the image, and if you remember, you will notice that the disk image is way less than the previous standard Python Docker image that we use. It's about 1.4 GB, 1.1 GB, I guess. But now you can see it is not even 100 MB, right? Then we will do a scout to view the vulnerabilities, right? You can see there are one high, right, medium, 3, and low 10, because we have included Python packages and other packages. These are coming from these vulnerabilities are coming from those packages, right? But if you do a Docker scout on the DHI image without including any packages, you will get a image without almost zero vulnerabilities, right? So I will do a comparison in the next section, so we'll see the differences, right? Then, but this is good because compared to the previous, we found more than 150 vulnerabilities, low, medium, high, right? But now it is reduced to like 14 vulnerabilities total together, right? It's considerably low. Then we will run the container, right, from that build image, right? Now we have run the Docker container, right? You can see the container is running, right? You can verify Docker container ls, right? So now you can see the DHI app is running, uptime 30 seconds, right? Okay, then I will run the curl commands to view the informations, right? Okay, so you can see the application is working as expected, right? Okay, good. Okay, now next step is actually we are going to do is a comparison, right? So first we'll do the comparison between our standard and our own standard image that we built from the official Python image and the DHI image we built from the Docker Hardened images. So first we will create the list of images, right, with this demo that we are going to do with demo, right? So you can see these two images are there, right? So one is standard and DHI image, that is Docker Hardened image, right? So first we're going to compare those two images, right? Because it is Docker Scout also give a very detailed view, right? Because of that, I'm going to use set to filter out the output, right? Right. So here, if you take a look at this overview, you can see the differences clearly, right? So you can see that this is the target image, that is our Docker Hardened image that we built on top of using Docker Hardened images, right? Then this is the image that we built based on the standard Python image, right? Then you can see the tag that we use, right? The platform architecture, right? Then this is very important part here. So you can see that the image that we built from the Docker Hardened images has only one high severity vulnerability and 3 medium and 10 low vulnerabilities, right? But if you compare it to the standard one, you can see it has 5 high and 11 medium and 149 low vulnerabilities. So it's very high ratio of vulnerabilities available in the standard, right? So in the bottom of the analyzed image, you can see the comparison actual. So you can see it is -4, that means 4 vulnerability less than the compared image, right? So this is a comparison basically. Then the size wise also you can see the comparison. So your standard Python image is 456 MB, right? But if you compare it to the Docker Hardened image, it is 35 GB. So you can see it is less than 421. So not GB MB, right? So it is 429 MB lesser than the standard image. Then also packages, also when you compare the packages, also you can see a huge difference. So in the comparison image, that is standard Python image, contain 615 packages, but in the hardened images you can find only 54 packages. It's it's 561 packages less than the standard Python image. Okay, so you can see the obvious differences between those two images. Now next we are going to use the same command, scout command, to compare the official DHI Docker Hardened image and the Python image from the standard Python image, right? So I'm running the command. So let's wait a little bit while. Okay, now the comparison is completed. So now you can see the two images that we are going to compare. So we are going to compare Docker Hardened images with the standard Python image, right? Then you can see the tag is the same, right? Then here vulnerabilities, this is what I mean, what I mentioned previously. So if you take the Docker Hardened images Python hardened image, you can see 0 vulnerabilities here because it doesn't contain any vulnerabilities at all, even lower level vulnerabilities, right? But if you take a look at on the standard Python image, you can see there are many vulnerabilities, like more than 150 vulnerabilities from many severities, right? So here you can see the difference. Then size wise also you can see a difference. It's Docker Hardened image is 22 MB, but the standard Python image is 412 MB. So yeah, Docker Hardened images is very much less compared to the standard. So the package wise also see a difference, 610 in standard Python image, and you can see it's 47 in the Hardened image. So if you see these two difference to comparison, the one you build and as well as the images that are in Docker Hub and the Docker Hardened images repositories, right? So you can come up with a clear conclusion that Docker Hardened images are actually hardened, right? Okay, next we are going to test non-root execution, right? So as I mentioned previously, Docker Hardened images are running as non-root user, right? But if you compare it to the standard image, those images are default run as root user, right? So let's take a look at whether we can run the Docker Hardened images with root user, right? First, I will run the standard image, right? Then I will use id command, right, to get the id of the running user, right, in the container, right? So here from there you can see clearly, you can see which user is running on the container, right? Okay. So if I run the id command in standard image, right, so you can see uid is 0, that is root, group id is 0, that is root, then groups also 0, that means this user is in the root group, right? So that is means way high privileges, right? That means someone broke into the container, then that attacker has more privileges to tamper with the container, and he can do a lot of things, right? So now we are going to do the same thing for the Docker Hardened images that we built, right, from using the Docker Hardened images, right? But there's a small problem here because you cannot run id in the Docker Hardened image because it is stripped down version of the image, because it doesn't include many tools, many packages, right? It only has the packages and the tools that are needed for running the applications, right? Because of that, we cannot use id, but you can use Python to get the information of the UID and the group IDs and those kind of things. So that's what I'm going to do here. So I'm running the import OS and I will output the UID and the group ID of the container. Okay, so here you can see the UID is 65,532 and group ID is 65,532. So this is the default UID and group ID that is running for hardened images, right? So that means it is not running as a root by default, right? So that's a good thing. So it doesn't have many privileges. Okay, now we saw that the differences between Docker hardened images versus standard images, right? So here is a quick comparison between those two images. I have added include in the README, so you can have an overview, right? So you can see the based image and improvement, right? It's more optimized compared to the standard Python image. Then you can see the really 91% of reduction in the image size. Then package count also you can see it's way improved, like 87% reduction, right? So when the CVE counts also you can see it's 100% reduction. So normal standard image contain many CVEs, but the hardened images doesn't include any CVEs. Then user wise also standard is running as root user, that's UID 0, but in the Docker hardened images it is running as a non-root user, usually UID 65532, that is secure. Shell access is available in standard Python images but not in Docker hardened images. Package managers are also not available in hardened images, so that means no one can get a shell access or download any packages. SBOM sign, so transparent, so that means anyone who use the image know which packages are included in the Docker hardened images, right? So signatures are also available, and build tools are included in the standard Python images, but those are removed from the hardened images because those are not necessary for any hardened images, right? So the standard images are maintained by community, but the hardened images are maintained by Docker officials, right? Then you also the same comparison I have shared with you previously in the demo, so you can see the exact difference. Okay, so that's all for this demo. I think you have got a good idea about overview about the Docker hardened images. So I think it's good for organizations and individuals to use Docker hardened images for securing their applications. So I would encourage and recommend everyone to take a look at the Docker hardened images and use it for the daily production or your applications. So thank you very much. So I will come back with another video like this around Docker, Kubernetes and DevOps.